Hi everybody, welcome to my E102 Turn project. My project was to draw a digit on a VGA display, send that digit over UART protocol and guess what digit it was on Python on my PC. So let's get started, shall we? So I'll start my Python code and let's switch to the VGA display. So this is the mouse that controls the cursor on basis 3. So when I move my mouse, the cursor also moves. This is a black grid that indicates you can draw here. It is a 14 by 14 grid. So when I press the left click button and draw, see, here's an 8. So I made a mistake over here. So when I press the right click button, I can delete it and make it into a better shape. So let's switch back. So it says the number is most likely 8. So it worked. Let me show you the image that we got. So here it is. So one of the bonuses that we get from using an FPGA is that FPGA is a parallel processor. So we can draw a display. We can send the display data to the computer and receive orders from the computer. So we can do that in a single clock cycle. So we don't have to wait, and it really helps. So the display is a black and white monochromatic display, but as you can see, the cursor is green, and you can draw actually any color you want, but I just chose black and white, but it is monochromatic. So one of the performance upgrades that I did is that the grid that you drew on the VGA display, it is a 14 by 14 grid, so 196 bits. It is monochromatic, so that saves a lot of space. If I were to send the entire pixel space of that grid, it's 350 by 350 pixels, so that would take a lot of space and a lot of time to send, because the UART protocol is a slow protocol. Mine runs at 57,600 baud per second, so that's like 57,600 bits per second. But 14 by 14 grids, especially grayscale monochromatic, it is very easy to send. It takes like 196 bits, so it is easier to send. One of the problems I ran into in this project, that machine learning was not working. I used the MINIST digits dataset. It has 10,000 hand-drawn digits on it, but my digits were not hand-drawn. It was monochromatic and it was very blocky. So I applied a bilinear filter, so that, as you can see, helped with the images. So the machine learning, it's not still amazing, but it works. Thank you for watching.